Hello there, we move on to the chapter 3, that is differentiation. The first lesson is on tangent lines and velocity. The first couple of lessons is not directly on differentiation. We just deal with how we can use a formula and everything. And similar problems, what we are studying in this lesson can be solved easily in the coming lessons when we learn differentiation. But now we will use these methods which are specified in this lesson. The learning objectives is to link and interpret the slopes of a secant line and tangent line, write the equation of a tangent line to graph at a given point using limits. We'll have to find the average and instantaneous velocity at a given point and solve mathematical and real life problems using derivatives. Now the keywords are secant line, tangent line, average velocity and instantaneous velocity. All the objectives and these keywords will be covered in this video. We will now begin with the first topic, that is the tangent lines. Now let us look at this figure. Is this a tangent line? I'm sure if you remember the circles lesson in the previous grades, you will know tangent is something that touches at the end, it should touch only exactly at one point of a curve or a circle or anything. So now if there is a curve, say like this, a tangent, I want to draw a tangent over here, it must be such a line that it just touches one point over here and then it doesn't touch it inside. Now here, this is a secant line which cuts at 2 points, right? This is a secant line, it's not a tangent line. Now how can we get this secant line to be a tangent line? What we can do is we can get it as closer as possible. If we bring these points closer and closer, you can see this point is constant. We need to find the tangent line at this point. We are bringing it more and more closer. If you zoom this up over here, you can see there's only a little bit of difference. Now when you see, it is almost becoming like a tangent line because it's a curve, but it just touches only a little bit. But exactly it must touch only one point. So I'm not going into detail of all the derivation over here, but it's explained very well in the textbook. But here now what we understand is we can find the slope of any point at a single point with this formula. Now what are we doing over here? This one over here, okay? But now here from this basic thing we can find the slope, that is, we know the slope is always given by y2 minus y1 divided by x2 minus x1. Now if you're thinking what is this f of a, f of a and f of a plus h, these are 2 points. Y means f of anything means the function. This is y2 and y1. Now y1 is the specified point, this one, right? Now imagine the next point is little distance. This h indicates some distance, some little distance away. So it is at f of a, if a is 1, but some little distance, it might be 1.1. This is the thing. Okay, divided by x2 minus x1. So this is it. Now this is simplified over here and written. Now this a and minus a and plus a cancels and you're remaining with h. But now if we take the limit of that thing to 0, that means we are going so close to that point that we are finding literally almost at that point, right? We have done this limit. So we will do the limit of this formula. See, now this formula is only the slope formula over here, but when we simplify, we get this in terms of h. H is basically another point which is a little bit away from it. And if we take the limit of h as 0, that means we are practically getting one single point. So this is how we can use it. And the equation of the line is always given by this. What is this exactly? Slope formula, let's all see up over here. The slope formula is m equals y2 minus y1 equals x divided by x2 minus x1. I'll just erase everything else. Now what you need to do is get an equation, right? See, now this one, if you look closely, it's the same thing, but what is done? It is just that everything else is taken to the other side and y is kept alone. Now here I'll move this x2 and everything to the other side. M of x2 minus x1 equals y2 minus y1. Let me take this y1 to the other side. It's going to be m of x2 minus x1 equals y2. Oh, sorry, I forgot to write plus y1. Okay. So y2 equals the slope of x2 minus x1 plus y1. This is the equation of a line, of a given tangent line. So now you can see m is the slope of the tangent line. We can find it by using the above formula, where limit h tends to 0. Now in the previous slide we had written secant. Why? Because that's the secant, because there are 2 points. But as we take the limit of this h, the distance towards 0, it becomes tangent line. And then this is, first part is m tangent line, x2 is the second point, minus the first point, plus the f of a, that is y1 equals y2. So now it's just that instead of y2 y1 we have f of a and x. That's it. So we will see a problem now, you'll understand much better. We have to find an equation of the tangent line to this particular equation of a tangent line to this curve, you know, x equals 1. So now let's just draw this. This is a parabola. You know, it's a parabola. X squared means parabola plus 1, so it will start at 1. This is the basic graph. Over here we have. Now at x equals 1, that means when x is 1, it touches over here, right? There we need to draw a tangent line, a line that only touches at one point wherever the graph is there at x equals 1. So what is this y value? It is at x equals 1, so substitute over here as 1 square 1 equals 2. So at y equals 2 you can see, and at x equals 1 the tangent line must only touch at that point and then never touch the curve. So we need to find the equation of this tangent line. For the equation of the tangent line, we know the formula y equals the slope of the tangent into x2 minus x1 plus y1. I'll not write x2 because y equals x. So this is it. So now, how do we do this? We know the points given over here. X equals, say over here x is 1. So, sorry, this will be x1 and y1. Whatever is given to us will be y1, over here y1. That was, we just now put 1 square, and this is x1, that is 1, and put over here as 1, and you will get y1 as 2. So these are the two values, and y and x will be standard because it's an equation. You know, equation of this particular curve is written as y equals x square plus 1. So that will be y and x. We need the tangent, we need the slope, sorry, not the tangent, slope. We need only the slope, everything else is known. x1 is known, y1 is known. How do we solve it? We use the formula which we just now derived a while ago. So we need to use this formula and solve the slope. Now let us do it. Here, this says the function of 1 plus h and function of 1. What is this function? This y given, right, is basically f of x. Okay? When we tell function of something, instead of x, we need to put this particular value. Now here we have f of x equals x squared. Let me write it down over here. F of x equals x squared plus 1. Now instead of x over here, instead of x in this function, we have to put 1 plus h. F of 1 plus h equals. Now, why are we taking 1 if you're thinking? Because x is given as 1. Okay. And see, over here it is a. Now, okay, I told you take it as a. This doesn't matter. In the textbook, they give you a, x, all that. That's fine. Just remember, whatever is the given value at x equals 1, x equals 2, x equals 3, that must be this value over here, okay? In this formula, that constant that will be given. H is unknown, okay? So that's it. If it was over here 3, then this would be 3. So that is what it is. Now here you have got 1 plus h, right? So in this equation now, instead of x, you should put 1 plus h, and don't forget the square plus 1. Now this is the first part. And what about the second part? Now we can simplify this, right? How do we simplify? It is like a plus b the whole square formula. Let us write it as a square, sorry. This is as a square plus 2 times ab plus b squared. Now let me write it over here. 1 square plus 2 times 1 into h is h plus h square. And then this plus 1 is there. We are just simplifying what is 1 plus h. Now we get 1 plus 1. We will write the highest degree first. It is h square plus 2h plus 1 plus 1 is 2. So this is the simplification of f of 1 plus h. I'll just repeat over here. Now this is the formula. You need to memorize this. The formula is written as f of a plus h, a minus f of a divided by h, where the limit of h always tends to 0. This h goes to 0 at the end. But we need to first simplify the inner things. A is always given in the question. Instead of x, we need to understand that whatever is given x value is the a over here. Now we need to substitute that as 1 here, and then here also a is there, substitute 1. So we get limit as h tends to 0 or as h approaches 0, the function of 1 plus h, because a is x given value 1 plus h minus f of 1 divided by h. That is what happened. Now here then what we did, f of h plus 1, f of 1 plus h. What is f of 1 plus h? In the given equation, wherever there is x, you should just put whatever is there over here. So f of 1 plus h, we have been given the function y, that is f of x, equals y means the function, f of x also means the same thing, equals x square plus 1. Now instead of x you have 1 plus h, so substitute instead of x as 1 plus h the whole square plus 1. And now use the power a plus b the whole square formula, that is a square 1 square plus 2 into both the terms, that is 2 into 1 into h, 2h plus h square. And then we rearrange and write the first highest degree first, h square plus 2h plus 2. That is only this part, minus what is the other term, f of 1. That means instead of x square it will be 1 square plus 1. So f of 1 is what? 1 square plus 1 is 2, because 1 square is 1, 1 plus 1 is 2. Now h is as it is, so I will just erase this and I'll write the answer over here. Here what happens now? We have to write h square plus 2h plus 2 minus 2 divided by h. Now plus 2 minus 2 cancels, and here h square plus 2h. You can remove the h common out, right? So I will just remove h common out. What is remaining? H plus 2 divided by, what is this? This is h itself. Now we can cancel this, and as what is remaining? M tan, the slope of tangent is h plus 2. This is the answer. Okay. Oh, sorry, I forgot to do the limit, right? Sorry, this is the formula. Okay, are we done? No. See, I just forgot the limit. Don't do this. Okay, this is very important. H plus 2 is correct. This much is correct. I'll erase this one over here for now. You can pause and see. This was for this term. This was for the second term. Now I'll just erase it all. And then let me just continue down. Okay. So I'll write it over here. Right. Now we got this over here. And next one, when we simplify, we get h plus 2. But what is something that I've not written? I've not written limit. See guys, this limit h tends to 0 is there. At the last step, we applied the limit. So even over here, there is limit as h tends to 0. Now this is what a polynomial. You can substitute the limit directly because it's continuous everywhere. So substitute the limit. What is the h value given as the limit? 0, always at 0, standard formula. So here it will be 0 plus 2. The answer is 2. What is this answer for? It is the slope of the tangent, m tangent. So this m tangent value is 2. So what we did just now is to find the slope of the tangent line to this equation at a particular point. If they don't mention at x equals 1 or x equals 2, you can't solve this because this formula depends on this x value. It will be at one specific point. And we can't find a slope until and unless we have 2 points, right? But here we are dealing with tangent line, so it only touches 1 point. So it will be at one single point. But from this formula, even though we don't have another point, we can find the slope. And this is what we have done. We found the slope for this tangent line. Let's see, it's 2. Let's see the answer. It is 2. That's how we do it. Okay, now here you can see this has been substituted. Instead of 1 plus h, it is written 1 plus h the whole square instead of x plus 1, and then minus f of 1 is what? 1 square, that is 1 plus 1. And then we substitute it, we simplify it using the formula a plus b the whole square, and then we get this simplification. 1 plus 1 is 2, minus 2 it's gone, 2h plus h square by h, and then you're removing the h common and cancels, and then apply the limit 0 and you'll get the answer. Now this is the slope, but still what is the formula remaining? We need to find the equation. What is the equation given by m, that is for the tangent, that's the 2 value, into x minus this value, okay, the given x value. So whatever is given, we consider it as a, right? F of a, or you can write x1, anything. Now I'll write a plus f of a. Now this is the formula, you can just generalize. And now here m equals what? M equals 2x minus a is 1 plus f of a is, over here instead of x you should put 1 square. We did it at the beginning. 1 square plus 1 was 2. Now we just substitute over here. 2 times x is 2x minus 2 plus 2, and this cancels. Your answer for the equation is y equals 2x. The tangent line's equation is 2x. So over here, that's it, y equals 2x. So you can see over here, if you had see, this is, yeah, x would be a 45-degree line. I mean, it's all the same, but now this is 2x. So that is the answer. So this is how we solve, we find the equation of tangent line using the formula of the tangent, and then using the equation formula, we directly substitute. So if you're writing it, you must use the formula depending on the given value, okay, and then you have to substitute the formula, apply the limit at the end once it's simplified, and then you can easily write the equation and solve. Now if you're wondering, okay, can I do this directly in calculator? Of course you can do it in calculator. We have done that already. You have to take values close to 0 and you can do it over here, but you need to do the substitution no matter what. See, now from here you can do it from the calculator, but it's very easy to solve it out, right? So if you're thinking, okay, it's hard to solve, now from this, once you do the substitution, you can try it using calculator. Now since I know this is a slope and you will get an answer, right, for a tangent, there is a point existing, so you will have a slope. So I'll directly put this in calculator, use the brackets appropriately. 1 plus h can't be written, it is x square plus 1, close the bracket again, minus, I'll write 1 plus 1 as 2 directly, divided by h is again x. Now x is corresponding to 0, so it should be 0.001. What is the answer? It's 2. So you can directly substitute and get the answer of 2, and then, but you need to know the formulas and solve it. This is how you solve this problem. I've taken a bit of time on this, but all the other problems, the method is same. So if you understand this problem thoroughly, when I'm going to the next problems, try pausing it and try solving it yourselves. So let's see the next one. You have to do the same thing. It's just that the equation is a little different. Now I will tell you one thing. Instead of x, you just take this as a and this as f of a. Okay, now please pause the video and try it by yourself, solve this, and if you're getting stuck, you can continue watching the video because I'll be explaining it now. First thing, the formula. Now the formula changes. See, the formula is what? Here 2. In the last problem, what did we have? 1. So based on this given value of where you need to solve, it changes. Now this equation, this graph won't be there, but just for understanding, this is the graph, this is the point, and this is the slope. This is the tangent line. Okay, now what do? Substitute over here. Instead of a, f of 2 plus h. So wherever x is there, what do? Write 2 plus h, and that's it. And over here, f of next one is f of 2. Now wherever 2 is there, wherever x is there, see, because we have two parts, right? Function of 2 plus h and 2. So wherever x is there, it's 2, that is equal to 1. So now we just substitute that. You can see, wait, let me just write it. It'll be f of no f, because you already see this is f of 2h, 2 plus h. This is the answer, right? You directly substitute over here. 2 divided by 2 plus h minus 1 divided by h. Now you can directly put in the calculator and solve, but we can also simplify. How do you simplify? Take the common term. Here it will be 2 plus h. Basically, you're multiplying and dividing, right, 1 with 2 plus h. So you'll have a common denominator, and then it will be 2 minus 2 plus h. It will be in bracket, divided by h. If you're thinking how this happened, see, if it's 1 and you need a common denominator, so you should make a common denominator for both, right? When you have a common denominator, right side is 1, you can multiply and divide by the denominator of this. So if you multiply this by 2 plus h divided by 2 plus h, what is happening? You have a common denominator now. 1 is gone and this is the thing, right? So write 2 plus h and solve. 2 minus 2 plus h. So now multiply this minus inside the bracket. Will be minus 2 minus h divided by, I'll take this is denominator, this is also, it'll be coming down, you know. So it'll be 2 plus h bracket multiplied with this h. Now you can cancel this out. It'll be minus h divided by 2h plus h square. Oh, why am I doing this? Sorry, I'll write it 2 plus h and over here as h. Why? Because I can easily cancel these two terms, right? It'll be minus 1 by 2 plus h. This and this cancels. Now this is your final term, but don't forget there is always a limit as h tends to 0, isn't it? Now substitute this as 0. What is the answer? Negative 1 by 2 plus 0, that is negative half. So this is the tangent, this is the slope of the tangent. I hope the steps are clear. So first you should see what is f of 2 plus h. That was 2 divided by 2 plus h. And what was f of 2? Here we got 1. Then we just multiply these two to solve. If you're getting confused over here, it's fine. I'll remove this. I'll just put it in the calculator and I'll show you. So what you must do is substitute this properly. Right over here, 2 divided by 2 plus h is not there, it's x minus 1 divided by x. And now calc near to 0, 0.001. It's negative 4.999. Now calc, even if you take the other side, which we did in the last chapter, it'll be negative half. If you put many zeros, it will come as negative half. Otherwise, it will come as negative 0.49999, which is 0.5. Negative 0.5 is the same thing. Okay, it's negative half. So this is how we found the tangent. The slope of the tangent. Now we know the slope of the tangent, then write it in the equation. Y equals slope of tangent mt into x minus a plus f of a. Now y equals, tangent was negative half. Now you can see the line is going downwards. It must be minus, so it's correct whatever we got. X as it is, minus a is 2. And what if you substitute x over here as 2? It will be 1. We solved it a while ago. So f of a is 1. Y equals negative half x plus half into 2 is 1 plus 1. You will have the answer negative half x plus 2. This is the equation of the tangent line, negative half x plus 2. Let's see the final answer. Yes, negative half. Okay, they have not simplified. They have just written like this, negative half x minus 2 plus 1. But it's better you write the simplified version. This is correct. But always it's better you multiply it inside and solve it and write the simplified version. This would be the most accurate answer. I hope you tried this by yourselves. If you didn't get, again, now try it by yourself again, practice it, and you will understand better. So then we will move on to the next problem. See, the same methods are done. Sometimes the methods might vary from your textbook, a little here and there. The methods which they use might be a little different, but ultimately the answer will be the same. Now here we have to graphically and numerically approximate the slope of a tangent line to y equals x minus 1 divided by x plus 1 at x equals 0. Now what is this? So graphically, how do you graph this? This is the graph. It is a rational function. It will be something like this. Now if you think graphically, draw a tangent line at x equals 0. Where is x 0? Over here. You should draw something like this, right? A tangent line. Okay, that's very bad, but you need to draw it from a ruler, so it'll come like this. Okay, this is accurate one. Now you need to find this tangent line. So if you know this graph, then keep a ruler over here and you can't do it very accurately, but approximately draw it. Okay, it'll be something like this. And now take any point which is a reasonable point on this from this tangent line. So we know 1 is at 0. What is the value at 0? X is 0. It's minus 1. So first point we'll take x equals 0 because it's given. The y value was minus 1. This is 1. And another point which is easy over here, 1 and 1. Okay. And now let's find the slope of these two. So x1, y1, x2, y2. Let me just write the slope. M equals y2 minus y1 divided by x2 minus x1. This is the basic, the crudest form of slope. Formula of slope. Now y2 is 1 minus y1 is negative 1 divided by x2 is 1 minus 0. The answer would be 1 minus of minus 1 is 1 plus 1 by 1. It is 2. 2 by 1 is 2. So this is graphically. Okay, the answer is, let's just check, it's 2. You can see over here they have done the same thing. They have written a lot of things, just you can go through it later. So this is graphically, we are doing slope. But what is the numerical method? Now imagine you cannot graph it and all that. So now we can do it numerically as well. So now we use this graphing point and we did it graphically. Now numerically we are using the formula. Not the formula. We are doing the limit method. What we did in the last chapter, in the first or second lessons, we did this. Let's consider, we know what x is 0, right? This is the x value. So take points which are close to 0. If 0, you can take minus 1 and 1. But in the textbook, it's taken as 1 and negative 0.5. It's fine. Ultimately, you're coming very, very close. That's it. So 1, x is 0, so don't take 0, take 1 and negative 0.5. How do you find the slope? Wait, let me just write. We know x1 is 1, x2 is this value, and y is over here. Just substitute the values of 0 and you'll get the answers. So what is, when x1, what is y1? It is 1 minus 1 divided by 1 plus 1. 1 minus 1 is 0, so it will be again 0. Okay, so that is the I have done a mistake over here. X value is 0, so this is wrong. Y1 would be what? Instead of x, substitute x1 value. Y1 would be, instead of 1, substituting the x1. So how much would you get? It would be 0 minus 1 divided by 0 plus 1, negative 1 divided by minus, it'll be minus 1. This is y1. Okay, this won't change. Now take a value which is closer to 0. Yes, 1 is obviously closer, so substitute. X2 is 1, y2 would be, instead of x you're substituting 1. Now 1 minus 1 divided by 1 plus 1, it'll be 0 by 2. The answer is 0, so you get y2 as 0. Now you use the slope formula, y2 minus, we did a while ago, right? Y2 minus y1 by x2 minus x1. Here y2 is 0 minus y1 is negative 1 divided by x2 is 1 minus x1 is 0. What is the answer? It is negative 1 by 1. It is minus 1. So that is how we get this first one. Okay, what did I do wrong? Sorry, it is minus of minus, that is plus 1, and it's plus 1, it's plus 1 here. Now the second thing, the same thing is done. Instead of x you put negative 0.5, you get minus 3, and then use this formula. Let me do this formula. This is now x2 y2, this keeps on changing. Y2 is minus 3, and x1 doesn't, y2 doesn't, y1 and x1 doesn't change. Minus of minus 1 divided by x2 negative 0.5 minus 0. Minus of minus is plus, so it is minus 3 plus 1 divided by negative 0.5. The answer would be minus 2 divided by negative half. It'll be multiply this, because 1 by 2, 2 comes up, it'll be 2 times 2. Sign changes to plus. 2 times 2 is 4, so that's why you get it. Or you can put in the calculator directly, you'll get the answer. It's up to you. Now guys, we have done this in the last chapter. Same thing, now approximate more closer. From 1 we are going to 0.1. It's a huge jump, but still you're going closer to 0. From negative 0.5 you're going to negative 0.1. Closer to 0. How about more closer? 0.01 and negative 0.01. As you go more and more closer and you find slopes just like what we did, where you just iterate more and more steps, you're going to get the values. See what is happening. You can see the slope is closing in on a particular value from 1.98 and 2.02. Which is the value there it's approaching? It's approaching 2. Yes, that was the value we got over here in the previous graphically, right? We got 2 when we did this. Same answer we will get even numerically. So then we can tell, yes, numerically and graphically it's the same slope. This may not come for exam. This is just an understanding problem. It's only for understanding. It's just that you do it graphically or numerically, the answer would be the same. But graphically what happens? Sorry, numerically what happens? You have to do iterations closing in on the given value of x. So that's the thing. And we have done this previously as well. Now then we will shift to velocity, the next objective. Now here velocity we know is distance is rate into time, and velocity over here can be given as sine distance by time. Now if you're thinking what is sine distance is like just displacement where 2 intervals are given. Okay, the actual thing is very complicated, but if you understand that when you have 2 particular limits, 2 intervals, you're finding the distance only between these 2 intervals. That is, you can call it as sine distance. Okay, we will see a problem, we'll understand better. Now here we have a problem that the position of a car after t minutes driving in a straight line is given by this equation over here at this particular time, 0 to 4. That is where s is the measured in miles. Okay, this s distance is measured in miles and t is measured in minutes. So whatever the answer you have over here, using this equation will be in miles. Sorry, it'll be miles per minute. Okay, not miles per hour, not miles per second, not meter per second, it's miles per minute. Now then approximate the velocity at time t equals 2. Let's say this is important. At time 2 we need to solve. Okay, anyways, let me remove that. Let's see what we are dealing with. Time at 2, right? So did they tell us exactly how to solve at time 2? Yes, but we can't solve it only at time 2. Whenever we find average velocity, we need 2 times. It can be from 2, say 4, and then you have x1, x2, and then you can solve, right? We need 2 points. Basically, it's like slope. We need 2 points, right? Here they have told approximate at time 2. So what we will do is we will average from time 2 to 4, because this equation is for what? 2 to 4. Let's do. Time t1 is 2 and t2 is 4, and this is same like the slope formula. It's basically y2 minus y1 divided by x2 minus x1, just that it's velocity, so we use displacement over here, the signed distance. This is the displacement equation. Here, how do we find this s of 4? Basically, sorry, let's consider this as x1 and x2, or t1 and t2, anything. I'll write the slope formula, okay? y2 minus y1 divided by x2 minus x1. Let's get everything in the same form, because it's the same thing, only the values we write changes. That's it. Now here, let's see properly. x1 is this, x2 is this. So now what will be y2? Y2 in the sense this one, this equation here. Instead of t, you must put 4 and 2. That's it. y1 and y2. So let me do with y1 first. y1 would be equal to, here wherever is 2, you should put 2 value. Sorry, a t, you must put 2. So half into 2 square minus 1 by 12 into 2 cube. Okay, you can just put this in the calculator, you will get the answer. Let's put it. Half is 0.5 into 2 square is 4 minus 1/12, 1 by 12 into 2 cube is 8. Now the answer is 4 by 3. Okay, that's 1.333 over here. This is y2. Sorry, yeah, y1. Sorry, y1. Now y2. What about y2? Same thing, but the value of x changes to 4. It'll be 4 square. It was 2 square 4, so I written 4. It is 2 square, and over here it is 2 cube, the 4 cube, and we get 8 by 3, that is 2.6. So it was 4 by 3 here, 8 by 3. So now I will just substitute in this formula. y2 is 8 by 3 minus y1 is 4 by 3 divided by 4 minus 2. What is the answer? Just everything in the calculator. It's gonna be 8 divided by 3 minus 4/3 divided by 4 minus 2 is 2. The answer is 2/3, or 0.667. Let's see. That is it. I hope this is clear. All you're doing, just like the previous problems we saw, the first 3 problems, same like that, but it's just that we are dealing with velocity here. Now if you got the answer 0.667, okay, you can use it as fractions or decimals. That's fine, you'll get the same answer. But now there is a problem. It's in miles per minute. We want generally in kilometers. Now kilometers is not required. Let's keep it in miles. Don't complicate the problem. Let's do it miles per hour, because that is a more better description, right? We have something per minute. If you are doing per hour, just multiply it by 60. You will get the answer. Multiply the answer by 60. Now it's 40. So we get 40 miles per hour. From minute to hour, it's just multiplying 60. Here we got 40. Okay, this is by averaging over 2 minutes. Now then, we can get more accurate answer, because see, now what it means is, now imagine you're driving, okay, from one distance to other distance. You started from your home and you wanted to go to your friend's place. It takes you 5 minutes, okay, from A to B. Just to make you understand, year to year. You drove like this, the road was there, okay, you went on the road. It took you 5 minutes, okay. Now your distance, the distance you covered was say 5 kilometers, and you took 5 minutes, so you drove 1 kilometer per minute. Okay, that is what it says. and the speed would be 1 kilometer per minute multiplied by 60. The speed would be 60 kilometers per hour. Okay, you drove exactly at 60 kilometers per hour, but this wouldn't be true. You might have got stuck in a traffic jam, or by a car in front of you, or a traffic signal, or you might have speeded at times. You might have gone at 100 where the speed limit was easily wherever the speed limit was high, you might have driven fast, and wherever the speed limit was low, you drove slowly. So it's not exactly correct, right? You're just taking from one instance to other instance and it's averaged. Same thing over here. You're not getting a accurate answer because this is over the time period of 2 minutes. In the 2 minutes, this person might even have stopped and then accelerated and then whatever, but it just shows 40 miles per hour. So let us take t as 2 and t as 3. This will give you more better answer. Why? Because now we are just averaging it over 1 minute. Let's do this. So over here, same thing. Substitute this values over here and substitute, get the functions s of t. I'm writing now s of t. It's the same thing. It's like y1, y2. Now t1, t2, 2 and 2. I'll directly do it in the calculator. So you have to substitute this over here. This first one will be the same. When you substitute 2, we got 4 by 3. That will be the same. But what about 3? So all you need to do is over here 0.5 into 3 square minus 1 by 12 into 3 cube. The answer is 9/4. 9 divided by 4. Okay. Now use this in the slope formula, that is over here. First 9 by 4 minus 4 by 3 divided by 3 minus 2 is 1. The answer is 11 by 12, that is 0.916. The answer over here, average velocity AVG equals 0.916, or that is miles per minute. Let's write miles per hour, multiply this by 60. Now you got 55. So it was 55 miles per hour mph. Now this gives you more accurate answer. Let's see. Yeah, it's 55 miles per hour. This gives you more accurate detail on the minute from 2 to 3, but still they asked us approximate the value of velocity at the time t. How do we do at the specific time t? Now you might have understood, say we need always 2 points, but now we have to ignore the second point because we need just a single point. Till now average requires 2 points, slope requires 2 points, but if we do, say for example, just a little distance, this h means just a little distance ahead, it can be 0.001, just small distance from the time 2 to a small distance 2.01, okay, the time. If we find that particular values, it will be more accurate, don't you agree? Now this is the similar formula what we did for the limit, I mean just now, the tangent, slope of the tangent. So what we are trying to say is, how about instead of having time 2, 3, 2, 4 over large distances, why don't we reduce it? Say from 1, 0.1, 0.001, 0.00. As you increase and go very close to time 2, you're getting different answers. See over here, basically whatever we did just now, right over here, we do the same thing, but it's just that it is with 2 and 2.00001. That's it. These are the two t1, t2. Now s of t1 would be the same, 4 by 3, but s of t2 would be, you have to just put this value instead of t and solve and then use the slope formula and do it. This is the answer. 1, you got 1. That means 1 into 60 is 60 miles per hour. So even in velocity, we are doing the same thing what we did. We are going to take the limit of this h as 0. When we take it towards 0, that means we are finding at that particular instant, we are taking 2 plus 0.0, very, very close to it. So this is what we will be doing. by using this formula. Okay, this problem, the first part, I mean, was just, this problem is just explanation. Now we will do another problem on the same concept using this formula. Now it's same like what we had done a while ago. It's just that we are dealing with distance and edge, distance and time. Here we are. We can try pausing the video now and solving this by yourselves, and then you can watch the video because I'll be solving it along with you. Here we have to find average and instantaneous. Now, one important thing. Average means you have 2 points. Average between two distances, between two times, from time 1 to 2. But instantaneous meant at a specific point of time. Now, if I'm telling you instantaneous time 2 means at this particular time I want to know what is happening. Whereas average means at time 1.5 to 2 what happened. So this is what it is. Now it's very simple to understand. Now imagine you're in the classroom. Now anyone is asking you what is happening from say 9 o'clock, from 9 to 9:45. You can say it is going to be physics, but okay, this is not that great example, but anyways, you just tell which is the period that happens, right? Now instantaneous means at that particular minute, at that particular time when someone asks you what is happening, that is that instant. Okay, I hope you get the concept what I'm trying to say. Anyways, now we will do this problem. Suppose that the height of a falling object t seconds after being dropped from a height of 64 feet is given by s of t equals 64 minus 16t square feet. Find the average velocity between times t1 and t2, the average velocity between 1.5 and 2, the time, and the average velocity between 1.9 and 2, and the instantaneous velocity at 2. So they have given an equation, the falling of the object in time t seconds. Okay, this is the displacement equation, and now times are given. We need to find the average. It's very simple. We have done it just a while ago. So we will do this one quickly, and then the other ones it's just the same thing, and I'll do the instantaneous one. So over here t1 and there is t2, so you need to find s of t1. How do we find this? You have to just put this 1 instead of t. It would be 1 square 1, 64 minus 16, it would be 58. Sorry. So here we substitute 1 and then we get 64 minus 16. So it'll be 58, sorry, not 58, 48. Yeah, 48. So this would be 64 minus 16, 48. And next one over here, it's 2. T is equal to 2. S of T2 would be 2 squared. So 16 times 2 squared, that would be 4. 16 times 4, it's going to be 16, 32, 64. It's going to be 0. Okay. So that's the answer. You can do it in the calculator directly. And now we need to find the average velocity. It is T2. I'll write the formula for once. S of T2 minus S of T1 divided by T2 minus T1. It's same like Y2 minus Y1 divided by X2 minus X1. All you need to do is substitute 0 minus 48 divided by 2 minus 1. The answer is negative 48. 2 minus 1 is 1. So that is negative 48 in terms of what is the distance? Feet per second. So the first one is negative 48 feet per second. Same thing needs to be done next over here for 1.5 and 2. It's the same over here. The first part is same. It's just that this part changes. 1.5 squared. So 1.5 squared times 16, and then the value changes. Here you can get it as negative 58. Try the last one. Here same thing. Pause the video. Try the last one. It will be same substitution is all over here, negative 62.4 feet per second. Now what you can see is just by changing some seconds, some part of seconds, you're getting different answers. But now let's find instantaneous velocity at exact time t2. How do? We do it from the new formula which you learn. So plus h over here, limit will be 0. So It's very simple. All you need to do is put this in the given equation. So now this 64 minus 16 t square. Instead of t, you need to put whatever is this, 2 plus h the whole square. You've done in the first and the second problem the same thing. And then over here, instead of t, you should put 2 square divided by h. Now simplify this. Here you're gonna get 2. Okay, here it's important to remember this formula. A plus b the whole square will be equal to a square, that is 2 square plus 2 times ab plus b square. A square would be 4, 2 times ab, 2 times 2 into h, that is 4h, plus b square would be h square, minus 64, this one. And now we here solve it up. Here multiply the 16 inside. Basic things, 64 minus 16 times 4 is again 64, minus 64 plus 64 cancels 0, and then you will get 4 again, 60 minus 64h, that's written over here, and minus 16h squared, that's written over here. And what about over here? Again, my 64 minus 64 is 0, so minus 0 this goes, so this is 0, this cancels. You're remaining with minus 64h and minus 16h square divided by h. Don't forget this. Now here you cannot substitute this limit as of now because it's divided by h. So take a h common. Now cancel this. Now it's a polynomial. It's easy to substitute. You can easily substitute h over here. It'll be 0 plus 4. It's 4. Negative 16 times 4. It's 64. So negative 64 feet per second is the instantaneous velocity at the point 2. Whereas we can see over here in the previous case, we were closing in on that value. As we go closer, from negative 48, it came negative 56, negative 62.4, but the accurate value is negative 64 feet per second. So this is the thing. And okay, if you're wondering why minus, you can see it in the question. I think so. It's being dropped from a height. Dropped means what? It's going downwards. Whenever something is going downwards, it is negative. Direction is negative. The velocity is not negative. It's just the direction. Negative indicates the direction. If it was going up, it would be positive. So if it's thrown upwards, this values would be positive. That's it. So that is how we solve these problems. I hope this is clear. The first part was just by using the slope formula, and this over here we are using this limit instantaneous velocity formula and getting the answer. To find the tangent, to find the instantaneous velocity, it's all this similar formula where limit of the distance from given point is tending towards 0. H is tending towards 0. Now we will see this one. If the function, interpreting rates of change, if the function f of t gives the population of a city in millions of people t years after January 1st, 2020, interpret each of the following quantities assuming that they equal the given numbers. Okay, you need to talk about each of them. So let's look at these. Now here they have told they're talking about population. Okay, the population of city in millions. This each function f of t gives you the population of each function in millions. So what does each each of these equations say? By looking at this, I can tell this is slope, this is slope, this is instantaneous. So let's see now, f of b minus f of a divided by b minus a is the average rate of function, right? So here the first one, it's average rate of change. Now you can see this means from 2 minus 0, it's from 2002 to from 2000 to 2002, because it's always A and B, right? From 2000 to 2002, if you use the formula, what is the x value? It is 0 and 2. F of A is 2002, 2000, 2002. But you don't need to write this, it's just written as a function. F of 2 minus f of 0 divided by 2 minus 0 is 2. That's what is there, okay? They have simplified the denominator. Now, that what is the answer? This answer. That means it is the average rate the population is growing, right? It is the population growth. This value indicates the average rate of people per year. See over here it's written grew at an average rate of so much per year. The slope indicates rate of change. Slope is what? dy by dx, rate of change. Here the average rate of change was 0.34 and from 2000 to 2002. Now the second one, you can see over here, f of 2 is the same thing, but minus f of 1. It would be divided by 2 minus 1, which is 1, so it's written nothing because it's divided by 1. This is the same thing, but from 2001 to 2002. This is what? And this is the average rate of change. I mean the population growth, average rate of people. So that is from 2001 to 2002. And that's it. And the last one over here would be instantaneous. Since 2 is used, x equals 2, right? This a value is 2. If it was from 2000, then over here x would be 0. But since over here 2 is mentioned, it would be the instantaneous rate of change at 2002. So this is the just interpreting, you're just telling what is happening. The last one is instantaneous rate of change of population at time 2, that means it's 2002 January 1st. And the city's population was growing at the rate of 0.3 million people per year, because they have mentioned it's in millions of people. This is just a basic problem on interpreting. And now then we will go to a problem, sorry for this, it's graph. Okay, I'm just trying to read this guff. Anyways, a graph with no tangent line at a point. Okay, there is no tangent line. Okay, so you can see there is magnitude. It's an absolute value. Absolute value is what? Point, sharp points. There is no, you can't draw a tangent line at a sharp point because it'll be the like this. You will never get a curve. Only at a curve we can draw a tangent point, right? So we cannot draw a tangent point at this. We have solved problems on this in the previous lesson. So when you look at this only, you can tell it does not exist. Let me just go to the final answer. We can just directly tell it does not exist because it's a absolute value function. But anyways, even if you solve, let's see, use the formula and try solving it. Here, what is the slope? Always right side it's positive, left side it's negative. Okay, but let us use the formula and prove it. Here we have, what is the x value? 0. 0 plus h minus f of 0 divided by h. Now what you do? You have to substitute this. Instead of x over here, you will get, first one is, I'll directly write it over here. 0 plus h, x is 0 plus h, which is only h. Okay, so I'm not writing 0 plus h, it's going to be 0, minus f of 0, so substitute 0, 0, magnitude of 0 is 0 itself, divided by h. So the answer basically you get is magnitude h by h. Now limit, there are two sides. Always remember there will be two limits at 0 for this. Why we do this? Because it will be positive or negative. We have done this in the previous lesson, same thing. Now whenever it's positive side, both this will be positive, this will also be positive, so it is h by h, that is equal to 1. Okay, fine, we get positive slope. Now the same thing we'll do at the negative side. It's minus here. As it goes to the minus, what happens? Substitute the same things over here. It will be magnitude 0 plus h, which is corresponding to h itself, minus 0 divided by h. Now here what happens? Whatever happens, this doesn't change sign, because the answer of any magnitude value, minus 2 or plus 2, it will be plus itself. So this side will be h. But down we have one more which will be minus h. So what is the answer? Minus 1. Okay, it's minus 1. So the answer is minus 1. So these limits are different for both. When it's less than 0 and greater than 0. So the thing is, okay, just look over here. Magnitude of h, this is supposed to be down here, minus, but minus up or down is the same thing. So this will be plus h, this will be minus h. Ultimately you'll get the answer minus 1. It is for, but you know, when you write minus, it means for both. Okay, we write it up itself, that's the thing. But it's supposed to be over here, because this can never be negative, it will be always positive, but the down one will be minus h. The answer is minus 1. So it does not exist. It's a simple problem. And then we can tell the tangent line does not exist because there are two different answers, because the limit does not exist. Okay, and that's the end of this lesson. I hope you have found this useful. It is just an introductory to derivatives, but it's not exactly derivatives. We are using formulas based on slopes. In the coming lesson, we can solve, once we learn derivatives, we can solve the same problems with such ease using derivations. So do stay tuned for the coming lessons. And if you're not yet subscribed to my channel, please do subscribe to it. You can scan this code or you can just click down over there on Best Math. It would mean a lot to me, and I greatly appreciate all those who are subscribed for all the support. Thank you, everyone, and all the best, and wish you all happy learning.